All right, I just want to make a quick video to go over our check-in from last week. And so that check-in said that you wanted to solve a system that had these two equations. We have x plus y equals 6 and 2x minus y equals 9. Now it mentioned two particular methods. The first way was to just use elimination. And so we're going to work on basically adding equations together to eliminate a variable. And then the second way was to use Gauss-Jordan elimination. Now these are just two different strategies, but our answer should be exactly the same, but we're just using a different process. And so just a reminder on our test that's coming up next week during Thanksgiving week, you will be asked to use particular methods. So make sure that you pay attention to which strategy, like the name of it, so that way you can use the correct method when I ask you to solve some systems. So using the first method of elimination, these are actually really nice equations here, because if you just try and add the equations together, we have a variable that will be eliminated, the y's, because one's plus y, one's minus y. So if I just add them up as is, I'm going to have x plus 2x making 3x's, and then we have our equal, and 6 plus 9 makes 15. So we've eliminated y, so now we have an equation in just one variable. So if we want to solve for that x, we'll just divide by 3 on both sides. That gets us x is equal to 5. So we also need to find a y, because for our system here we have two variables going on. So we could take our y and plug it back into either the first or second equation. If we plug it into the first equation, we're going to look at that x plus y equal to 6, and we're going to substitute that 5 in. So 5 plus y equals 6. If you solve that for y, you will minus the 5, so we get y equals 1. So we have an x value of 5 and a y value of 1, and we can write that as an ordered pair, 5, 1. And again, graphically what that means is that's the point where these two things are linear. It's where they will be meeting. All right, so the next thing that we want to do is use Gauss-Jordan elimination. So I'm going to start by rewriting this as an augmented matrix, the system. So our coefficients in front of the x and y are 1s, and in the bottom one it's a -1. So we'll have 1, 1. We draw our line, 6, 2, -1, 9. Okay, so this is our matrix, and our goal is to put this into reduced row echelon form, which reduced row echelon form is when we have our diagonal of 1s, and then we'll have 0s below and above those 1s. So this again is our goal. So then if we want that to happen, we I like to start by making sure that first upper left corner is a 1, which is yay. And so then we'll want to get 0s above or below it. So in this case, just below it. So we want to make the 2 go away. So we're going to use the 1 in that column. And so we know that to make a 2 cancel out, we need a -2. So we're going to take -2 times that first row, add it to row 2, and that will make my new row 2. So please make sure that you're writing down the row operations, and it should be written in that way here. You could do some little side work, or you could do it in your head to come up with the matrix that results. Okay, so I'm going to write the matrix here. Don't just write random numbers everywhere. We want to make sure this is all organized. So for side work, I mean, I would actually multiply -2 times row 1. That'd be -2, -2, -12. And I want to add that to row 2. So 2, -1, 9. We're adding those together. That's 0, -3, -3. And again, that's my new row 2. So I'm going to write 1, 1, 6, because my first row stayed the same. My second row is 0, -3, -3. So once I've reached the goal, I'm going back to my goal of having 1, 0 in that first column, then I want to work on the second column. And I don't want to start with the 0, I start with the 1, so that way I'll be able to use it. So I want to make a 1 in that bottom right corner. In this case, we're looking down at that -3. We want that to be a 1. So what we're going to do here is take -1/3, or you could say divide by -3, either way, to make my new row 2. So, or you could say row 2, oops, wrote that down wrong, let's undo that. We could say row 2 divided by -3, because that would make a 1. Either way is totally fine. So those are my row operations, which will turn into this matrix, 1, 1, 6. That top row stays the same. The bottom will be 0, 1, 1. All right, so again, with my goal, as soon as I get that 1, I have my diagonal of 1s going on here. So remember, we're trying to make these guys 1s, and then we need 0s below and above it. So that's what we're gonna work on, is getting that 1 to be a 0. So to make a 1 cancel out, we need a -1. So we're gonna take -1 times that row 2. So that 1 that we just made, we're gonna use it. I'm multiplying it by -1. I'm gonna add that to row 1 to make my new row 1. Again, you need to be writing down these row operations and understand how they work. So I could, again, do my little side work. If you're going to do the little side work and not do it in your head, make sure that you write it down, that it's your little side work or scratch. So -1 times row 2 is going to be 0, -1, -1. Row 1 is 1, 1, 6. So when we combine that together, I'm going to get 1, 0, 5. So my matrix, my row 1 is now 1, 0, 5. My bottom row is 0, 1, 1. Now it's in reduced row echelon form. If I go back and write the system that's represented here, my x column, my y column, I'm going to have x plus 0y, so just x equals 5. And on the bottom, we're going to have 0x plus 1y equals 1. So we get x equals 5, y equals 1. Again, 5, 1 is our answer. And again, it might look like it's longer, but it's because I'm kind of showing all of this little side work. If you could do that little mental math in your head, it actually goes quite fast. But again, you want to make sure you're showing all of our matrices. So hope that helped.